Hello students, I hope all you are safe at home. We should follow the instructions given by the government time to time. We should wear mask properly and maintain social distance whenever we go outside. Okay. In the previous class, we have discussed some multiple choice questions based on the chapter One Eye and the Colorful World. Okay. So in today's class, let us see some multiple choice questions based on the third chapter, that is electricity. Okay. A cell, a resistor, a key and an ammeter are arranged as shown in the circuit diagrams of the figure. Okay, given figure, the current recorded in the ammeter will be A, maximum in first circuit, then B, maximum in second circuit, C, maximum in third circuit, same in all cases. Which one may be correct? How can we connect the ammeter in the circuit? Gauri Shankar? Yes. We should connect the ammeter in series in the circuit. So here, how the ammeters are connected? Yes. This one is connected in series. Second circuit also connected in series. Then third one also connected in series. Now how can we connect? That is, if there is a negative, the ammeter is near to the negative terminal of the battery, then negative terminal of the ammeter should be connected there. Okay. If the ammeter is near to the positive terminal, then positive of the ammeter should be connected to the battery. Okay, so that's also correct. Here also near to the positive terminal. So here positive terminal and then here there is negative terminal. So ammeter is connected in this way. Okay, so the connection is correct. So it is connected with the resistance. You see that connect the resistance value connected in the circuit also same in all the cases, isn't it? Then in any one of the cases it will be maximum? No. The current will be same in all the cases, isn't it? Then the battery voltage also same. If nothing is given, it's a variable one R. So voltage is same. So all the circuit, the current will be same. Okay. So option B is correct. Okay. Right. So we should check whether the ammeter connection is correct or not, then voltage is the same or not. Okay, then resistance value also we should check. Then we can say in which circuit the current is maximum or it is same in all the circuits. Okay, right. Then second one, in the following circuits, heat produced in the resistor or combination of resistors connected to a 12 volt battery will be. Okay, so we have to find what is the heat produced in the resistor or combination of resistor. We have to find that will be same in all the cases. Then minimum in case 1, maximum in case 2, maximum in case 3 is given. Which one may be correct? So what is the formula for the heat developed in the circuit? You know, the heat developed in the circuit that is equal to I squared R into T. That is I squared R, that is power, isn't it? Power into time. Or we can write into, but here what is given? V, voltage applied across the resistor is given, then resistance is given. So we can write that the power, our heat energy, we can write V squared by R into T. So we have to find what is the heat in each and every circuit. So here what is the R value? V is the same in all the circuit, isn't it? T also same in all the circuit. So here we can write it is a H is inversely proportional to R. Heat energy is inversely proportional to R. So we can write here only 2 O. Then here 4. Isn't it? So then here two resistors are connected in parallel. So what will we get? The resultant resistance, that is 1 by R is equal to 1 by 2 plus 1 by 2. R we can write R is equal to 2 by 2, that is equal to 1 ohm. So here resistance 1 ohm. So resistance is small here, then greater in the circuit. So greater in the circuit means minimum. So in the case 2, it should be minimum. But what is given here? Maximum in case 2 is given. Isn't it? But actually, okay, so here it is minimum. R value is minimum. So maximum in the case of 3. So what will we get here? So maximum in case 3. Isn't it? Resistance value is small in the third case. It is 1 ohm. Here 4 ohm. Here 2 ohm. So resistance is small. Then heat energy will be large. According to this equation, which is inversely proportional to R. So option 4 is correct. Okay, the maximum in case 3. The electrical resistivity of a given metal wire depends upon its length, its thickness, its shape and nature of the material. What is given? Electrical resistivity of a given metal wire. So resistivity of a metal wire depends on temperature and nature of the material, already we have studied. Isn't it? So here also the option D is correct. It depends on nature of the material. It does not depend on length and thickness, shape. Okay. So we should read the question very carefully. Then whatever the things we have studied in the theory part, we should analyze. Then you should write the answer for that. Okay. Next question. Identify the circuit in which the electrical components have been properly connected. Okay, which circuit is? In which circuit the components are connected properly? How can we connect ammeter? Yes, ammeter should be connected in series. Then how can we connect voltmeter in the circuit? Naval, yes, voltmeter should be connected in parallel. Okay, whether voltmeter is connected in parallel and ammeter is connected in series. So here, the first diagram you see that ammeter is connected in series, voltmeter also connected in series, isn't it? It is not connected in parallel. So the first circuit is wrong. Then second circuit is here voltmeter is connected parallel, ammeter is connected in series. Okay. We cannot say it is correct. Okay. So we will not put the wrong mark here. Okay. Then because we have to check whether the positive terminal and the negative terminals are connected in the correct way. Okay. In the third one, see that ammeter is connected in parallel, voltmeter is connected in series. Is it correct? No, it is wrong. This circuit also wrong. Then fourth one, yes, voltmeter is connected in parallel, ammeter is connected in series. So again confusion arises, isn't it? Second circuit and fourth circuit, voltmeter is connected in parallel and ammeter is connected in series. Okay. So if any difference is there, see that here voltmeter is connected, positive terminal is connected to the positive terminal of the battery, then negative terminal through the ammeter is connected negative terminal of the battery. Okay, both. This part is same for these two circuits. But here see that ammeter, the negative terminal of the ammeter is connected to negative terminal of the battery. But here positive terminal of the ammeter is connected to negative terminal of the battery. Which one will be correct? Yes. We should remember that in the case of ammeter and voltmeter, positive terminal of the voltmeter and ammeter should be connected to the positive terminal of the battery. Then negative terminal of the voltmeter and negative terminal of the ammeter should be connected to the negative terminal of the battery. That is a rule. Okay. So, all the meters, that is positive of the meters, should be connected to the positive terminal of the battery. Then negative terminal of the meters should be connected to the negative terminal of the battery. If we see the circuits according to that rule, this is wrong, isn't it? So, fourth one is wrong. Then third one is correct, isn't it? Because here positive terminal of the voltmeter is connected to the positive terminal of the battery. Then negative terminal is connected to negative terminal of the battery. Ammeter also, negative terminal is connected to the negative terminal of the battery. Then positive one is connected to the positive terminal of the battery. So, second circuit is correct. That means option B is correct. Okay. Option B is correct. Do you understand? Yes. Then, what is the maximum resistance which can be made using 5 resistors, each of 1/5 ohm? What is the maximum resistance value which can be made using 5 resistors, each of 1/5 ohm? If the resistors are connected in series, what will you get? Yes, the resultant will be greater than that of the given resistors. Okay, so here to get the maximum value of resistance, we should connect, that is 1/5 ohm should be connected in series. So if we connect these things in series, what will we get? Is 1/5 plus 1/5, because the 5 resistors given, isn't it? So 1/5 plus 1/5 plus 1/5, that is equal to 5 divided by 5, that is equal to 1 ohm. So this option is correct. Okay, maximum resistance of 5 resistors should be. Okay, so maximum resistance you have to obtain using 1/5 ohm resistance. That will be only 1 ohm we will get. Okay. Then, what is the minimum resistance which can be made using 5 resistors, each of 1/5 ohm? 5 resistors, using the 5 1/5 ohm resistor, we should get the minimum value. Already we know, if the resistors are connected in parallel, then the resultant resistance will be less than that of the given resistance. Isn't it? So, if we connect 5 resistors in parallel, we will get very less value. So, what will we get is 1/R is equal to 1 divided by 1/5 plus 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 1 divided by 1/5. Then, okay, we will get that is 5 plus 5 plus 5 plus 5 plus 5, that is equal to 25. But 1/R is 25, isn't it? So 25 is here. So based on that, don't put the tick mark immediately, because 1/R value is 25. So R will be 1/25. This is a result. Okay. So option B is correct. Okay. So to get the maximum resistance, we should connect all the resistors in series. To get the minimum resistance, we should connect all the resistors in parallel, then obtain the resultant value. Okay. The proper representation of series combination of cells in the figure for obtaining maximum potential is, 4 diagrams are given. We have A, first one is correct, or B, second one is correct, or C, third one is correct, or D, fourth one is correct. Okay, we have to find. Then, which one may be correct? Is here. Let's consider here first cell has the potential V. Then here how many cells are? For example, I am saying that here 4 cells are connected. Isn't it? 4 cells are connected means 4V we will get. But here, see that the third cell, negative terminal of the cell is connected to the negative terminal of the second cell. Suppose that is considered V plus V, 2V, but here it is in the reverse direction, so we have to subtract it. So minus V, that is 2V minus V, V. Here again there is positive terminal is connected, so plus V. Okay, so we have to put the negative sign if the cell is connected in the reverse order. So we will not get the maximum potential. The second cell is connected to the negative of the first cell. So again here these two cells are connected together in the reverse direction. So 0. Then here the negative terminal, again this also, here also negative terminal is connected to the positive terminal this way, the reverse direction. So again this combination also we will not get maximum potential. Here also the cells are connected in the reverse order also. Okay, so here also we will not get the maximum potential. So only the correct circuit is the first one. So option A is the correct one. That means you should remember that to get the maximum potential, positive terminal of the one cell should be connected to the negative terminal of the another cell. In that way it should be connected seriously. Okay. In that way it should be connected in series. That means here negative terminal of the first cell is connected to positive terminal of the second cell. Negative of the second cell is connected to positive terminal of the third cell. Negative terminal of the third cell is connected to positive terminal of the fourth cell. Okay, so in that way it is going on. So maximum potential we will get in this combination only. Okay, so option A is correct. Then next one, a student carries out an experiment and plots the VI graphs of 3 samples of nichrome wire with resistances R1, R2 and R3 respectively. Which of the following is true? A student carries out an experiment and plot the VI graph of 3 samples of nichrome wire with the resistance R1, R2, R3 respectively. Which of the following is true? This first one is given. R1 is equal to R2 is equal to R3. Is it correct? Okay, for that to check which one is correct, let us see there is a common potential. Let us take the common potential for all these curves. Potential is same for all the curves. There is, okay, according to Ohm's law, we know V is equal to I into R. V divided by I. So here V is constant, isn't it? We have taken a constant. So V is the same for all the curves. So V is constant. So R is inversely proportional to I. Okay, inversely proportional to I. So from this we can draw the line perpendicular to the y-axis. It gives there is a current through the third resistance. Then here also we can draw the line perpendicular to the y-axis. Then it gives the current flowing through the second resistor. Then here also we can draw the line perpendicular to this one. We will get this I1. This is the current flowing through the first resistor. So which one is greater here? I1 is greater than that of I2 is greater than that of I3. Isn't it? So I1 is greater than that of I2. I2 is greater than that of I3. That order. But here we have found R is inversely proportional to I. If I is larger, R will be small. Therefore, we can write here R1 is less than R2 is less than R3. Okay. R is inversely proportional to I, current flowing through the resistor. So here we can write R1 is less than R2 is less than R3. Whether this one is here. If we see this answer, here We cannot find directly because here you can see R1 is less than R2 is less than R3. But here what is given? R3 is greater than that of R2 greater than that of R1. So in the reverse order we can write. Okay. So R3 is greater than that of R2 is greater than that of R1 because I3 is less, so R3 is greater. Then I2 is greater than that of I3, so R2 is less than that of R3. Okay, this way we can write. So option C is correct. R3 is greater than R2 is greater than R1. So option C is correct. Okay, so we should keep any one of the quantity constant. Instead of keeping P, we can keep this I also constant. We can keep I constant, but we should draw the line perpendicular to this line that should cut the three curves. So from there, which one is greater? V1, V2, V3, or which one is greater? We can say. Okay, that way also we can do the problem. So we can find by keeping the any one of the value constant, we can find the another value. Okay. Yes. If the current I through a resistor is increased by 100%, assume that temperature remains unchanged. The increase in power dissipation will be A 100%, B 200%, C 300%, D 400%. Okay. Suppose let us consider. So here the current flowing through the resistor is equal to I. Then it is increased by 100%. So the new current I dash, we can write I plus 100% of I, isn't it? That means here the current I through a resistor is increased by 100%. So we can write I plus 100% of I. So what will we get? I plus 100 divided by 100, the I, that is equal to 2I. So 100% increase means, okay, that is, we will get new current will be 2I. So here, what is the power dissipation? What is the formula we have studied? Power dissipation P is equal to I square R. Okay. So initial power is I square R. Then final power, that is equal to I dash square into R. So we will get 2I the whole square into R. Or we will get 4I square R. So new power is P dash is equal to 4I square R. But what we have to find? The increase in power dissipation only we have to find. So increase in power dissipation means final power minus initial power. That is only the increase in power dissipation. So P dash minus P, that is equal to 4I squared R minus I squared R. So you will get 3I squared R, or we can write 3P. Isn't it? So P dash increase in power, that is equal to 3P, or in terms of percentage, if we write, it will be 300%. Okay. Therefore, percentage of increase in power will be is equal to 3P divided by P into 100. So you will get 300. So 3 equal to 300%. So option C is correct. Okay. Next one. Which of the following represents voltage? Work done by current into time, work done into charge, work done into time divided by current, D work done into charge into time. Okay. What is the relation between voltage, work done and charge? We have studied, isn't it? Rihanna, can you say the equation? Yes. potential difference V is equal to work done by charge. We have studied, isn't it? Work done by charge, isn't it? Okay. Whether there is any equation is there? Work done by charge? No. Work done into charge only there. But in terms of current is given. So what is the relation between current and charge? Ravidev? Yes. That is I is equal to Q divided by time. Yes. Q is equal to I into T. That is charge is equal to current into time. Okay. So we can substitute here. There is voltage that is equal to work done by current into time. So whether this equation is there in the given option? Yes, the first option is work done by current into time. So option A is correct. Okay. This way we have to do the we have to attend the multiple choice question. Okay. So whatever we have studied, we should recollect that. Then based on that, which option may be correct? You have to do that. Okay. So here this equation also simply we cannot write work done. Suppose if that is directly given, we can write. But here in terms of current and time is given. So what are the formulas we have studied in this chapter? We should apply. Then we should find the equation. After that only we can select the option. Okay. In the next class also some more question answers we will discuss. Okay. So notes and assignment will be given through Google Classroom. We will meet in the next class. Thank you. Hari Om.